All right. So let's talk for just a minute about translations. So there are two ways that we can translate. It will either be in coordinate notation that's going to look like this: x plus something, y plus something, and you're going to do whatever the rule says. So if it says x minus 5, then that means you're going to subtract 5 from the x. If it says y plus 2, that means you're going to add 2 to the y's. Does the x move me left, right, or up, down? Left, right. And the y moves me up, down. Are there any questions on this type of problem?
No, ma'am.
Okay. So then we go here, and we started talking about vectors, and we started talking about arrows, and it's going to have both what?
Direction and magnitude.
Direction and magnitude.
Y'all aren't even doing it right.
Now, Ken had a question.
No, we're in class.
Ken had a question on ones like number 9. So when I'm looking at number 9, is that vector mn or nm? Mn, because we're following the arrow. Is that vector moving left and right?
No.
So that means that my first number should be 0. But it's moving up, so it should be positive
Whatever it moved up.
Was it 7?
6.
6. Yes, it was 6.
Okay? But now 10 would be only moving left, right.
Negative 11.
So negative 11, because it's moving to the left, 0.
I did all those.
Are there any questions on that type of problem? Just identifying the vector.
Those are some quality students.
Okay? All right. The next page was translating with a vector. So you graph the first one. You look at your vector. The first number moves my x. The second number moves my y. And you do whatever it tells me. So, for example, on number 12, we're going to move to the right 4, but we're going to move down 1. Now, I have the keys to this, so if you did something and you want to check, I will get those out in just a few minutes, okay? But is there any question on that type of problem?
No, ma'am.
Okay? What about writing the translation rule?
No, ma'am.
These ones at the bottom. Do I start with M or M prime?
M.
M. You always start with the regular letter and move to the prime. Okay? So on translations, do you have any questions? Because they are on the quiz next time.
Oh, good.
Okay. Then I would like for you to get out reflections.
If you insist.
Oh, she insists.
Oh, it's been insist.
Yeah.
Be quiet. We don't jerk around. This is the fun.
Okay, the first section for reflections was reflecting over an axis. And the only time we really miss these is, guess what we do wrong?
Go over the wrong axis.
We go over the wrong axis, or we count wrong. I messed up 2 graphs last class. I know. I've gotten my life together. I was hungry. So please read what axis you are graphing over. If Thomas 1 or Thomas 2 graphs and it goes off the graph, guess what?
It's wrong.
It's wrong. I will not give you one that goes off the graph in here. So be careful. So are there any questions on reflecting over the X or Y axis? Okay. So let us go to a horizontal or vertical line. Now, if my memory serves me correct, we only did 5. Did we also do 6?
No. I did.
No. You did, but not in class. Okay. So let's go to number 8. Number 8 is reflecting over the line y equals negative 5. Is the line y equals negative 5 horizontal or vertical?
Horizontal.
Horizontal. So we're going to graph the triangle, but we're also going to graph 1, 2, 3, 4, 5, and we're going to draw this horizontal line that we're going to reflect over. So if you did not do number 8, if you would go ahead and graph y equals -5 and the triangle MNP. I actually graphed this one wrong in the other class, so I'll be careful this time. We do not care about the axis. Okay, it's irrelevant here. We are counting from the line. So how many spaces from the line is M?
3.
So that means we have to go 3 this, and that's M prime. Okay, what about N? It's 1 away. So that's N prime.
So we're gonna write it.
And P?
3.
So 3 more.
2.
And you're reflecting over that line. Bigger what? Oh, no. We're always counting if it's a horizontal or vertical. The only formula is when it's diagonal. Okay. All right. So what is the ordered pair for M prime? -6, -2. P prime. Can work this one apparently.
Actually, I just did it like I did. Man, can you're so smart.
Well, I appreciate somebody answering my question. So -1, -4. So Sparks, does that answer the okay? And McGee, does that answer your question? Okay. So are we good on graphing over a horizontal or vertical line?
Yes, we are.
All right.
I have a question.
Yes.
Is a trapezoid, doesn't it have to be equal?
Yeah.
I got to one of the problems
And
and
I
it was
There's 2.
Yep. And isosceles trapezoid does, but not every
okay, well, I was
trapezoid.
not confused. I didn't know. So I just.
Okay, so the question was, in a trapezoid, do these two lines right here that are not parallel to each other have to be equal? Can you listen or no? Because I feel like you're not.
No, it's just
So, an isosceles trapezoid, yes, but every trapezoid is not isosceles, so these do not have to be the same length. All right, so this is the first set of rules that you have to learn. Everything else we've done from beginning yesterday to now, you could count everything. You're going over, you're going up, you're going down, you're reflecting, whatever. But now we have to learn our first 2 rules. So we're going to reflect over the lines y equals x and y equals -x. And those are diagonal lines. Now, we will also reflect over lines that are not just these, but these are like the basic ones that you have a rule for. We can reflect over anything. We can reflect over y equals 1/4 x minus 6. But that's a whole different ballgame. So let's talk a second about y equals x. So y equals x, if it's in the form y equals mx plus b, m is my, b is my. So what is my slope of this line? 1. What is my y-intercept?
0.
So when I graph this, where do I start?
0.
At 0, and it's a slope of 1, so it's going to look something like this. Okay, what about y equals -x? Where am I going to start?
0.
But my slope is, okay, so we're going to reflect over these diagonal lines. Okay, so let's go back to number, I don't know what that was, 9. And I want you to graph the triangle first, and then I want you to graph y equals x. And then we're going to talk about what to do. counting to this line. So as long as you sketch it correctly, I'm fine. You don't have to actually make, you know how the other ones when we did like the distance, we needed to be real precise because we're counting to it. We're not counting to these. So just sketch the line. There's going to be a rule for these. Now, these rules are also written on that sheet that I said this is very important, and Ms. Jackson should have put it on colored paper. These are also on there, but I want to write them on here as well. So if you are reflecting over the line y equals x, you're going to take your ordered pair, x, y, and you're going to make it y, x. You're just going to change the order that they're in. So instead of -5, -2, we're going to graph -2, -5.
Oh my goodness.
And for y, we're going to make it what? And then z, 1, -1.
Next time.
Did you switch the signs on?
That's all.
We don't switch any signs, we just flip the order.
Yes.
Yes. Don't switch any signs for this one. All right, so then I'm going to graph. Now, if you get to the test and you are completely like, I have no idea what to do, can't remember, you can use slope to get there. You can say, well, where is x in relationship to that line, and then go the same way to x prime. But it will just be easier for you to learn the rules because there are times when I do one where you don't have a graph. Okay? Now, I'm going to write the rule here for this one, but the next one we're going to do is going to be a y equals -x one. So, for y equals x, you just flip the order. For y equals -x, flip the order and change the sign. -y, -x. So I would like for you, I think it's 11. Yes, let's do 11. But I'm going to leave this for a second while you're writing that rule down. And 11 is reflecting over y equals -x.
You still draw the same line to the middle.
That's y equals x. We're doing y equals -x. That means my slope has to be negative.
I still have a 100.
All right, so you're doing 11.
Yeah, you have a 100.
This gunner's just a unit.
You're doing 11. Did I give y'all back your little extra credit sheets?
Where?
No.
No, that's what I got.
Okay, I'll give it back to you.
Wait, did you not count out of a half?
It was a quarter.
Did I make it?
You know what? It would have been so much more. I could have got
How many
like
points did you get?
maybe
Could've
100.
got like 130.
I might have gotten 100.
It's not added to the test.
Oh, has it been added yet?
Well, yeah.
Okay,
It's not added to the test.
She
I thought
put
was.
it
It's out of
she put
zero.
it, she put it out of 0.
Okay. So when I put it in there, it won't average. So it'll only, you have to look, it'll say like 8 out of 0 or 8.25 out of 0. So it won't give you the average because you can't divide by 0. But it's basically just added to the top.
Is it doing the same thing as if it's like
Well,
added to the test?
Because it's not like tests and quizzes and all that, it's not like they are more percentage points. It's like everything on the top's added and everything on the bottom's added.
See, that weirds me out because we didn't do that.
All right, so you should have graphed your square, and then this is y equals what? Y equals what? -x, so we got to go this way.
Why do you have to graph the line?
Because I need to know what I'm reflecting over. It also helps you to figure out, did I reflect this right? Even though I know the rules, did I reflect what I need to reflect?
Wait, do you have to actually draw the second shape?
Haven't we been drawing two shapes every time?
Y'all
I forgot to draw.
I have.
Yeah, I didn't draw it on the other one.
Alright, so we're changing xy to negative y, negative x, right?
Wait, where'd you get? Oh,
Where'd I
never
get-
mind. I forgot to put D. Mine was a triangle.
Oh, that's tragic.
Um,
Alright, so what is my A prime gonna be?
That would be.
Negative 3, 1. B is gonna be negative 6, 0. Negative 5, negative 3. And negative 2, negative 2.
Who's a good mathematician?
Me.
Everyone in here.
I'm amazing.
Alright, and then you're gonna graph the second. If you want all the points.
Mine didn't look.
Mine looks super cool. Super duper cool.
Wait, where are you from?
You flip them and change the sign.
Yeah.
Because it's
like
negative.
reverse.
We have all the points you see.
What if it is x equals negative y?
I don't know. Maybe hers is just neither.
Oh, no, she changed.
I did, I just messed it up. Alright, so we have reflected over y equals negative x. Please stop doing that. She has a class.
Yeah.
Alright.
Can y be negative?
What do you mean?
Negative y equals
What are you talking about?
If negative y equals x, then I would divide by negative 1. So y would
Oh
equal
my
negative
gosh.
x.
Are you ever gonna do that to us?
That's only genius.
Alright, now this last section, we are identifying the line of reflection. So for most of this, it's pretty easy. We just look and say, what are we reflecting over? Okay? So when I look at 13, what is my line of reflection? What are these shapes being reflected over?
Y-axis.
The y-axis. So that's my
Do
answer.
you just like draw it over it, or would you just put Y?
Just write y-axis. Hey, Gardner and Thomas, if y'all can't stop talking, please move away from each other. All right, look at 14. When I look at 14, does that look like it's being reflected over a horizontal or vertical line?
No.
No, it definitely looks like a diagonal line. So is it being reflected over y equals x or y equals negative x?
Negative.
Y equals negative x.
So cool, yeah.
What? Okay, on 15, does that look like it's being reflected over an axis? No. So remember that your line of reflection is the same distance from like R and R prime. So
It's x equals
we've got to go right here, smack dab in the middle, correct?
negative 3. X equals negative 3.
X equals negative 3 because X equals negative 3 is going to be our vertical line
What would it be Y equals?
because Y
Because
equals is a horizontal line.
Every 3, negative 3 number is on there. Negative 3, 1.
I don't know.
But it's going up and down. So, no.
Okay, baby, listen to me. The line X equals 6 is a vertical line. It's not an axis, it's a vertical line.
Yeah, the axis is
Right. Y equals is a horizontal line. Okay? Not the axis, we're looking at the lines. Okay, now let's look at 16 for a second. Don't look at the shape. Just pick a point. So if you pick T and T prime, don't try to look at the shape being reflected. Those are 2 away from what? So So this is going to be the x-axis that it's being reflected over.
Yep.
Don't get confused between an axis and a horizontal and vertical line.
Yeah.
Okay? All right, I want you to do 17. I think everybody can do 18 without help. Do 17 real quick. Don't tell me the answer yet. And while you're doing that, I'm going to pass out rotations. Rotations are easy
Oh, I don't
cheesy.
like those. That's like when it's 180 and 90 and all those.
Those are the things like you have to know.
Hey, I heard that it was stopped up, so if it is, go in the front. Because that seems disgusting.
Drink it anyway.
Drink it anyway.
Can
Yeah, you can take a few days off of school when you get
The Inca.
Yeah.
It's spitting up goo.
What you get.
From drinking school water.
They see
Just drink the standing water.
Like it's just sitting.
Conversation.
Okay, what on number 17? What is this reflecting over? Y equals 1. All right. Okay, guys. If you have too many, just hold it. I'll get some. Okay. So Z and Z prime are 1, 2, 3, 4, 5, 6 apart. So go 1, 2, 3 halfway and draw a line. And so that's going to be Y equals 1 is its line of reflection.
You know where 18
Is 18 a horizontal or vertical line?
Neither.
It's going to be what? Diagonal. So it's going to be Y equals X because it's going to be over a diagonal line. Okay. Now, there's probably 12 examples on here, and we're probably at the most going to work 2 of these because here's the deal. If you know your rotation rules, okay, if you know your rotation rules, then that's it. You just do what the rule tells you. There's no thinking involved. But we're going to rotate over things that are not just rules. So that's where it's going to get more difficult. So we're not going to spend a whole lot of time on these. You're going to learn the rules for these. The quiz that you are taking next time is only on translations and reflections. Okay, so I've done everything that's on the quiz. Is this on the quiz?
No.
Surely
Okay. All right, everybody, look. Did Thomas get one? Did y'all have enough for him? Okay, then Piper, I'll get in a minute, okay? Just keep it for a second. All right. So everybody, look at the clock up there on the wall.
How much time?
Yes.
Okay?
40 minutes.
So if I am at 12 and I go to 3, this way, I'm at 12, I go to 3.
Mm-hmm.
How many degrees? 90 degrees. Clockwise. Right? If I go from 12 to 6,
That's 180.
that's 180.
Right.
Does it matter if I go from 12 to 6? Does it matter if I go clockwise or counterclockwise? Will it change the number of degrees? Will not. So if I'm facing this way and I want to turn towards the door, it doesn't matter which direction I turn, I'm still going to be at 180 degrees, correct? Okay. Now, if I want to go from 12 to 9, clockwise, how many degrees?
270.
270. But our rules for rotations are going to be counterclockwise, which means the opposite of clockwise. So if I'm at 12 and I want to go 90 degrees counterclockwise, what number am I at? 9. 180 doesn't matter. And if I'm at 12 and I go 270, I'm at 3. Oh, 270 counter.
Oh, you're talking
All right. So,
How do you know, James?
translation
the bell rings at 12 minutes.
was a slide. Reflection was a flip.
This is a spin.
Rotation is a
Spin.
Turn.
turn.
Oh.
A turn around a fixed point called the center of rotation.
I like that.
A turn around a fixed point called the center of rotation. The figure is going to rotate at a specific angle and direction. The figure is going to rotate at a specific angle and direction.
Orange.
Though the figure can rotate around any fixed point, which we'll get to those in a minute, the most common center of rotation is the origin. These are the easy ones that you're going to have rules for. What's the origin again?
The 0,
0,
0.
0. So if you look at this picture right here, I'm at the origin. Now what you need to understand about rotations about the origin. Generally a rotation is, I have my pen this way and it's rotating like this, correct? But that's not rotating about the origin, that's rotating about a point in the middle of the pen, okay? But here, when I rotate about the origin, I need you to be thinking about the coordinate plane is turning. It's like we put, remember when you were in like elementary and they gave you one of those little brads that you stuck through and you had to make a little spinner or something like that? You're turning the coordinate plane. This is what is fixed, the red dot. So you're not spinning this triangle in quadrant 1. If you're in quadrant 1 and you go 90 degrees counterclockwise, you're turning that triangle to quadrant 2.
Interesting.
If I go 180, I'm going to go to quadrant 3 and then 270 to quadrant 4. Okay? So, let's write these rules down. You can memorize these rules or you can learn a little trick. I'm going to show you the trick. So if you're going 90 degrees counterclockwise, your ordered pair is XY. We have to have a rule to change it. Every time you go 90 degrees counterclockwise, you're going to take your ordered pair and you're going to switch the order that they're in. So it's going to be YX, and then you're going to change the sign of whatever ends in the first spot. So every time you go 90 degrees, take your ordered pair, switch the order. Change the sign of what lands in the first spot. So 180 is 90 more, right?
Yes.
So if we're at negative YX, and we're going to do the same rule, we're going to switch them.
Negative X.
Negative X, negative Y. So you're going to take the ordered pair that you have, negative X, negative Y. So every time you go another 90 degrees, you're going to take the ordered pair, switch it, and change the sign of whatever lands first. So what is 270 going to be?
Y negative.
Y negative X. Now, some people just choose to memorize those three. It just helps me to remember every time I go 90 degrees, switch their order, change the sign of what lands first. So 360 should get me back to what?
XY.
XY. Which 360 is back where I started. All right, so a rotation, all you're going to do is graph it, and you're going to look at whatever direction and degree they're sending you in, and you're just going to change your order pairs. All right, so one is triangle, and we're going 90 degrees counterclockwise. So that means we're going to change our XY to what?
Negative YX.
Negative YX. All right, I want you to start graphing.
Are all of them like 8 by 8 or whatever?
Yes.
Most of the time, sometimes there's 10s if the graph gets too big.
You still do.
Okay? So you're just using your rule, writing the new order of pairs. Now, I'm not going to ask you what quadrant it's in, but you should just be aware when you start. If I begin in the first quadrant and I'm going 90 degrees counterclockwise, I should end up in the second quadrant. Okay? So you should be self-aware of where this should end up. Why on number 2 does it not tell me a direction?
Because
180 doesn't matter. All right, go to the very last one in this packet. I think it's like number 14, 15, 14.
What? Yeah.
I think, okay, 14's fine. All right. So I've got to be aware because what does that say? Do I have a rule for clockwise?
Not yet.
Not yet.
Sure.
So what should I do?
Make one. You need to make
90 counterclockwise. So I need to use the rule for 90 degrees counterclockwise. Okay? So you've got to read what it's saying and you've got to think, oh wait, that's clockwise. So I need to do the opposite and I need to go 90 degrees counterclockwise, which means I'm going to change your XY to negative YX. So don't just look at 270 and start going. You're paying attention to what it's saying, then you're graphing. But on the test, is Miss J going to put a big thing that says clockwise examples, be careful?
Yes.
Heck no. She's going to just put clockwise and expect you to pay attention.
I did not draw that.
Where was your original figure? What quadrant? Quadrant 2. And if you're in quadrant 2 and you're going 270 degrees clockwise, what quadrant are you going to end up in? 3. So your original figure should be in quadrant 2. Your new figure should be in quadrant 3. Now, if you know the rules, is this a problem? No. We just have to learn our rules, and then we know what to do. So is there any questions on this type of problem? Feel like we can do this if we know the rules?
Yep.
Okay, keep that out. You're going to need your rules. But what we're about to do is going to be a little more, we have to think a little bit more, okay? Because we're going to rotate about something that's not the origin, okay? We're going to rotate about just some random point on the coordinate plane. Think you can do that?
If I figure out how to do it.
Yes, ma'am.
I have a question. If you like rotate a triangle by its center, would you have to like? Okay, so what I'm thinking, would you have to like find the midpoint between the two like well,
You got a lot of stuff.
Miss
And then
Jackson.
find the center
You-
of the
you just
fighting
wouldn't
Miss Jackson.
Carter said he
point.
wants
Carter said he wants stuff
You
with
just
some
said
harder.
that.
He feels like this is kindergarten.
But he said he just wants it. Nobody
Just
We
him.
actually have to
He said
find
he
what's
wants the
called the
really,
centroid.
really fun
The
stuff.
that?
Eccentric.
The very center. Wait, but would you get that? Would you get that by like
Overly
finding
fun
the
madhouse
two points
circus
and then
act.
between
Fun
the
time.
line those 2 points make and then the third point?
No,
I mean midpoint.
basically find the average of the three vertices.
Oh,
You have three vertices, so you have to.
so average of like X, Y.
Plus X
We really
X
need
plus X plus X divided by three.
Miss
Okay.
Miss Jackson.
Yes,
Roger
Roger.
said that he wants something a lot harder. He feels
I-
like-
Perfect. This
he
is gonna
said
be
he feels
good
like
He
now.
said he
kindergarten
wanted the
harder.
really, really fun stuff.
Okay. So we're gonna take and we're gonna rotate, but it's not gonna be about the origin. Okay? It's gonna be about just a random fixed point. Okay? So it says a figure can be rotated around any fixed point. In the example to the right, ABC is rotated 90 degrees counterclockwise about the point 2, 3. We can use vectors to rotate a figure when the center of rotation is not the origin. So we're going to follow the steps on the first one. Honestly, it's not hard. It's just tedious. So then I'm going to let you try one. All right, so they gave you this really big graph and all this room. Consider triangle XYZ with vertices X, Y, and Z. Follow the steps to the left to find the coordinates of the image under a 90 degrees counterclockwise rotation about the point 1, 2. So what I'd like for you to do first is graph that triangle and plot the point 1, 2. Graph the triangle and plot the point 1, 2. Okay. Got that graphed? All right. So we're going to use vectors to do this, okay? So we're going to use 3 vectors. We're going to go from P to X. We're going to go from P to Y. And we're going to go from P to Z. 3 vectors. P to X, P to Y, and P to Z. Now I'm not going to draw the vectors because it gets really a lot happening up there. So when I'm doing vectors, left, right first, up, down second. So to get from P to X, how far do I go over?
3.
Okay, 1, 2, 3. 1, 2, 3, 4, 5. That's the vector from P to X. Do you agree?
I agree.
Okay. Go ahead and do PY and PZ without me. Check them in just a second. Are those numbers up there ordered pairs?
No.
No. They're a vector, okay? They're telling me this is how far I'm going. But for just a second, we're going to pretend that they're ordered pairs. For just a second. And we're going to use the 90-degree counterclockwise rotation rule. And we're going to make new vectors. Okay? So what's the rule for 90 degrees counterclockwise? Okay? So instead of 3, 5, it's going to be what?
-5, 3.
negative 5, 3. So we're using the counterclockwise rule for rotations, and we're changing the vector. So this one's going to be negative 3, 7. And then the bottom one's going to be, okay. Now those are not ordered pairs. Those are vectors. So we're going to go to P, and we're going to go negative 5, 3. So we're going left or right? 1, 2, 3, 4, 5. 1, 2, 3. And that's going to be x prime. And then y, left 3. 1, 2, 3, 4, 5, 6, 7. Y prime. And then negative 1, 5. Negative 1, 1, 2, 3, 4, 5.
So you're going off of the point.
So you're going from P. So you found what your vectors were, and then you changed your vectors using the rotation rules, and then you're at P the whole time. And then you're counting with the new vectors. Now here's where y'all mess up, and I don't want you to mess up. When you go to write the ordered pairs for x prime, you do it just like you've been doing since 4th grade. 1, 2, 3, 4. 1, 2, 3, 4, 5. Negative 4, 5. It's not the vector anymore. It's the ordered pair for x prime. So what is the ordered pair for y prime? Negative 2, 9. So Nichols, this one doesn't have 8. Remember you asked me if there were only, so this one has 10. So just be careful. And then Z is 0, 7. Okay, so you're about to do one of these on your own. So you graph the figure, and you graph the point. You plot the point. Okay? And then you figure out what your vectors are. And you use the rotation rules to change your vectors, just like you were changing an ordered pair. Graph the new one and write down the ordered pairs. So I want everybody to try number 2. Quietly, give everybody time to think. Just think through it, okay? And then we'll check it in just a minute. And this is a square, so it should have 4 points. Oh, excuse me, rectangle.
What did you say number 1?
Oh, I see. That really wasn't number 1. Let's do 1. I think that's what everybody's doing. Are we all doing 1 or 2?
1.
I said 2, thinking that was like the second one. Let's do number 1, like the one at the bottom of the page. Sorry, that's on me.
It'll be okay, James.
It'll be okay.
You'll be fine.
We're here for you.
We're here for
That was
emotional
mine.
support. Shut up, Carter.
I mean, I'm sure your mom didn't want to change your diapers every time either, but she did for you, okay? Because she loves you. I'm gonna start graphing, you keep working. So up there is the original graph and the original vectors. Yours may be out of order than mine, but check your stuff and see if I got it right. Okay, now, what do I do with those vectors again?
Do the 180 rule.
180 rule. And what's the 180 rule?
You switch both the signs.
So negative x, negative y, right? Okay, somebody check. Did I do them right?
Yep.
Okay. So those are not ordered pairs, those are vectors. So, and y'all thought Miss Jackson had messed up, right? Because it almost went off the graph.
Almost.
Nope. Oh my goodness.
I thought you didn't.
I go sleep.
So cool. You want to cut it? No, I was actually asking for a cookie.
Yeah, I thought it was
wanna
at
do
90,
cookie.
and I did the 90, and then I was like, whoa.
Sugar cookie or
Okay, now, Kinch. Now, the last step is I have to write my ordered pairs. Okay? My ordered pairs are just like I've done since I was itty bitty. So what is the ordered pair for C?
1 -8.
1 -8. What about D? -2, -8. Then I got -2, -3, and 1 -3. Those aren't ordered pairs. Those are vectors. You have
Someone
to
just
go
tried to come in
from
here.
there and go right one down two. These are not ordered pairs. You've got to start from A, right one down two. Okay. Now I'm going to change the assignment sheet a little bit because I didn't know how far we were going to get today. So please listen very carefully to what I'm about to say.
Did we get farther or shorter than you wanted to?
Shorter, but it's okay.
Or
I just never, we hadn't done 70-minute classes in a hot minute, so I just didn't know how far we were going to get. All right, so next time I see you, you have a quiz.